You're listening to DTF HN for March 16, 2026. I'm your structurally compromised host, Jack Hacksman. We are your daily tech feed for Hacker News, a website where people who build load-bearing walls argue about which ones are decorative. Today's got that restless energy where everything you trust turns out to need tending. Let's get into it. When you build distributed systems, you learn something early. The systems with the strongest consistency guarantees are the ones that fail the hardest when those guarantees break. A database that promises eventual consistency can lose a node and keep moving. A database that promises strict serializable isolation. When that one breaks, everything downstream shatters because every other component was built on the assumption that the guarantees would hold. This research from frontiers in political science applies that same principle to political systems, and the findings are sobering. Across 62 countries, from New Zealand to Iran, they found that when people perceive corruption, it predicts lower social trust almost everywhere. But the magnitude of that effect is dramatically different depending on the type of government. In democracies, corruption doesn't just erode trust in institutions. It erodes trust between people. In autocracies, it barely registers. The researchers identified two mechanisms, and both deserve the first principles treatment. The first they call normative amplification. Democracy makes an explicit promise: equality before the law, impartial institutions, a level playing field. When corruption breaks that promise, citizens don't just lose faith in the corrupt official. They lose faith in the entire social contract. The signal propagates. If the system designed to be fair is rigged, then maybe everyone around you is rigging things too. The second mechanism is what they call representative contagion. In a democracy, you elected these people. They came from your community, your district, your neighbors. Corrupt officials implicate the citizenry that chose them. In an autocracy, the ruling class is understood as separate. Their corruption doesn't reflect on your neighbor. One of the Hacker News commenters called this a tautology. Corruption matters more, where trust matters more, but that misses the point. The finding isn't obvious, it's structural. The very accountability mechanisms that make democracy function. Elections, transparency, the social contract, are the same mechanisms that make democratic societies fragile to corruption. The antibodies are also the attack surface. This matters right now, concretely, for anyone thinking about institutional design. Open, transparent, accountable systems are better systems. That's a core belief worth defending. But this research says something uncomfortable. Those systems require active maintenance. The openness that makes them legitimate is the same openness that makes corruption so devastating when it occurs. You can't just build the open system and walk away. You have to tend it. The accountability structures aren't just featured. They're load-bearing walls, and the people who corrode them, whether through negligence or intent, are threatening something they may not fully understand. And if you want a case study in what happens when accountability structures meet a very motivated private contractor, pause, let's talk about Palantir. In Usumnayet, the British government hired a private company called the GCHQ's predecessor to handle signals intelligence analysis. Within 3 years, they discovered the contractor had built a parallel intelligence picture. Not by stealing classified documents, but by correlating the unclassified ones. The metadata, the shipping manifest, the personnel rotations, the procurement orders. Individually, noise. Together, a map of Britain's nuclear deterrent posture. That program was shut down and the capability brought back in-house. 44 years later, we're watching the same pattern, except this time the contractor is Palantir, and the scale is incomparably larger. two senior systems engineers inside the Ministry of Defense have gone on the REH cord. Anonymously, but on the RE cord. To say that Palantir represents a national security threat to the United Kingdom, and their argument is technically precise in a way that deserves attention. The UK government's defense has been that all data remains sovereign and under the ownership of the MO. The engineers call this ignorant, and they're right too, because it reveals a fundamental misunderstanding of how modern data analytics works. Here's the engineering reality. Palantir doesn't need your data. They need access to your data, which they have across the NHS, the MOD, nuclear weapons agencies, defense logistics. What they extract isn't rows from a database. It's the transform layer, the metadata, the relationships between entities, the derived insights. And those insights, those belong to Palantir. One source described it perfectly. 3 unclassified data points. Titel of turning size mores of prisaftrasdraak. A NATO part number, a destination address, an arrival date. Individually meaningless. Combine them through Palantir's aggregation layer, and you know a nuclear submarine will be at Diego Garcia on April 4th. That's not data theft, that's intelligence production. And it's happening inside a proprietary black box controlled by a foreign entity. This is the bootstrapism question at its sharpest. A country's intelligence apparatus, the thing that keeps its citizens safe, is being intermediated by a closed proprietary system owned by a single individual in another country. The UK population's data, health records, defense logistics, nuclear operations, flowing through one company's analytical lens. You couldn't design a more perfect single point of failure if you tried. The engineering community in the comments is asking the right question. Why does this need to be Palantir? The analytical capabilities they provide. Data fusion, entity resolution, graph analysis. These aren't magic. Open source tools exist. Sovereign capability can be built. Countries like France and Estonia have done exactly this. The tools exist, the knowledge is available. What's missing is the political will to build sovereign infrastructure instead of renting it from someone whose interests may not always align with yours. So what does sovereign tech look like when you shrink it all the way down to one person, one home, one voice assistant that actually works? Now run this forward 5 years. 5 years ago, Google Home worked beautifully. Then they killed the local API. Then they started requiring cloud accounts for basic functionality. Then the latency crept up. Then features disappeared behind subscription tiers. Every single person who built their smart home on that foundation watched the ground shift beneath them. Not because about the obvious, the technology failed, but because someone else held the off switch. That's the context for what this Home Assistant community member has built, and the engineering deserves real admiration. They've assembled a fully local voice pipeline. Speech-to-text via NVIDIA's Parakeet model running through OpenVINO with 300 millisecond inference on CPU. Large language models via llama.cpp with prompt caching, bringing response times to 1 to 2 seconds on a 3090, and text-to-speech through Kokoro. The whole stack runs on a B-Link mini PC with the USB 4 eGPU enclosure. It's elegant in its modularity. Every component is swappable. Every piece is inspectable. What impresses me most is the model testing rigor. They've benchmarked 6 different models across 4 capability dimensions. Multi-device tool calls, context awareness, misheard command parsing, and false positive rejection. That last one matters enormously. A voice assistant that activates on background conversation and then acts on misheard gibberish isn't just annoying. It's a system that degrades trust. The fact that certain 20 billion parameter mixture of experts models handle all four categories reliably on consumer hardware. That's a threshold moment. Imagine if every home had this. A voice interface that understands turn on the pan means turn on the fan, that knows which room you're standing in, that never sends a single audio frame to any external server. One commenter is even experimenting with analog rotary phones as voice satellites using existing phone jacks. That's the kind of creative adaptation that only happens when people can touch the entire stack. The cloud will always be easier, but easier isn't the same as better, and rented infrastructure isn't the same as owned capability. What this community is proving is that the gap between local and cloud voice assistants has collapsed from unusable to 1 to 2 seconds. The tools exist. The models are good enough, and nobody can take them away. 4 stories in, and we're still finding things that make me want to build something. Let's keep that energy going. Voygr is a YC Winner 26 startup, tackling something deceptively fundamental. Their claim, Google Maps can tell you a restaurant is 4.2 stars. Open till 10. What it can't tell you is that the chef left last month. Wait times doubled, and the regulars moved on. And they're right. Maps AP is give you a snapshot frozen in amber. Voygr wants to build what they call an infinite queryable place profile, combining structured place data with fresh web context like news, articles, local chatter. Now, let me play devil's advocate for a second. You might think, doesn't Google already solve this? They have Street View cars. They have billions of user contributions. They have more data than anyone on Earth. Surely, freshness is a solved problem at Google scale. Except it demonstrably isn't. Voygr have benchmarked how well LLMs handle local place queries. Even the best models get 1 in 12 wrong. And here's the number that makes you wince. 25 to 30% of businesses churn every year. A quarter of the physical world reshuffles annually, and the infrastructure just doesn't keep up. The world doesn't emit structured, eye-closed events. Nobody files a pull request when they rebrand. Their first product is beautifully scoped, a business validation API that tells you whether a place is actually operating, closed, rebranded, or invalid. They describe it as continuous integration for the physical world, which, as someone who's watched CI pipelines, is both a great metaphor and a slightly terrifying one. They aggregate multiple data sources, detect conflicting signals, return a structured verdict. The timing matters because agents are about to make this problem dramatically worse. When 40% of Google searches already involve local context and AI agents start actually booking restaurants and scheduling appointments, sending users to closed businesses isn't just annoying. It's a trust-destroying failure mode. The founders came from Google Maps, Apple Search, and Meta ML infrastructure, which means they've seen this gap from the inside. One commenter pointed out the irony. Building an infinite place profile while their website went down from 45 minutes of Hacker News traffic. Fair. But the API itself and the GitHub repo are what matter here. They're opening access to developers. The code is on GitHub, and they're processing tens of thousands of places daily for enterprise customers already. The real question is whether place data freshness becomes a label, like geocoding or routing, that every app just expects to exist. If it does, building it as open infrastructure rather than a walled garden is exactly how you prevent the next Google Maps lock-in. Open infrastructure preventing lock-in. Pause. That's the whole philosophy, and nobody has lived that philosophy longer than FreeBSD. The top comment in this thread is a guy who's been running FreeBSD on his home server for 10 years. 10 years. And his one complaint is that he once crashed the machine by messing with the speaker. That's it. That's the failure mode. He broke it on purpose, and it broke. This article is a love letter, and normally love letters make for boring reading, but the comment section turns it into something more interesting. A support group for people who quietly run critical infrastructure on an operating system most developers forgot existed. One commenter ran a FreeBSD collocated server through multiple generations of hardware. Another tried to move their home server over but hit a wall. Image assumes Docker. Docker assumes Linux. And suddenly, you're trying to pass through Intel QuickSync to a buy VM and questioning your life choices. The pattern is consistent. People love FreeBSD in theory. They run into the ecosystem in practice. And this is where the open/closed lens actually matters, but maybe not the way you'd expect. FreeBSD is open, radically open. The documentation, which every single commenter mentioned, is legendary precisely because the project treats knowledge as infrastructure. The handbook isn't marketing. It's architecture documentation that happens to teach you Unix fundamentals along the way. The author printed the entire thing on a laser printer he convinced his parents to buy for university. That handbook, printed in 2002, still contains relevant information today. Try that with any Linux distribution's wiki. But here's the tension. FreeBSD is open in code and closed in ecosystem gravity. Docker doesn't run natively. Hardware vendors don't test against it. Machine learning frameworks assume Linux. The system is technically free and practically, constrained. Not by its own choices, but by the assumptions baked into everything around it. One commenter nailed it. They said FreeBSD felt coherent. Unlike Linux, which is a collection of parts negotiating with each other, FreeBSD is an operating system. Singular vision, the base system, the kernel, the user land. All developed together, all documented together. The cathedral model, and the cathedral is beautiful. The author uses KDE, compile times, as a clock. Fans running means it's before 4 a.m. Fans silent means you made it. There's something deeply human about measuring time by the rhythm of your tools. That's not nostalgia. That's craftsmanship, recognizing craftsmanship. FreeBSD doesn't need to win the desktop. It just needs to keep being what it is. Proof that coherent design, obsessive documentation, and evolution over revolution can sustain a system for decades. The tools exist. The handbook is still there. And apparently, so are the fans. Moving on. Andrej Karpathy built a tree map of the entire U.S. labor market. 342 occupations. 143 million jobs. Every rectangle sized by employment count. That part is straightforward BLS data visualization. The part worth paying attention to is the pipeline underneath it. The tool ships with scrapers, parsers, and a system for writing LLM prompts that score and color every occupation by whatever criteria you define. The default view shows projected growth, median pay, education requirements. But there's a fourth toggle. Digital AI Explorer. And this is where it gets honest. Karpathy published the exact scoring prompt. You can read every word of the rubric the LLM uses to rate each job from 0 to 10. The logic is transparent. if your work product is fundamentally digital. If you could do the entire job from a home office on a laptop, your exposure score is inherently high, 7+. The reasoning is that AI capability in digital domains is advancing on a steep curve with a very high ceiling. Roofers score near 0. Software developers score near 9. But the real contribution isn't the default AI exposure map. It's that the coloring pipeline is open. You clone the repo, write a different prompt. Exposure to humanoid robotics, offshoring risk, climate vulnerability. Run the pipeline, and you get a different map. The visualization becomes a lens you can swap. One commenter calculated that $3.5 trillion in U.S. salaries represent the total addressable market for AI companies. 10% of that is an Apple-sized revenue stream. That arithmetic is cold, but it's not wrong. And having a visual tool that lets you see where those dollars concentrate changes how you think about it. The BLS data has known limitations. Their projections lag reality. Their growth forecasts have historically been unreliable. Karpathy says this plainly. This is a development tool, not an economic publication. The value isn't in the specific scores. It's in the infrastructure for asking questions visually and changing the question whenever you want. The whole thing is on GitHub. The prompts are readable. The methodology is forkable. Anyone can challenge the assumptions by writing better ones and running the same pipeline. This is how analysis should work. Not a conclusion handed down, but a machine for generating your own. Woven on. One comment in this thread is 5 words long. I'm too afraid to turn it on. That fear. About DNSSEC, a protocol that's existed for decades. Tells you everything about the state of internet security infrastructure. Here's what actually happened. As of today, March 15th, 2026, every certificate authority on the planet is required to validate DNSSEC when it's present on a domain. When a conche checks whether it's allowed to issue a certificate for your site, it now must verify that the DNS response it received hasn't been tampered with. The padlock in your browser just got a stronger chain behind it. Think of it like notarizing a deed. For years, we've had a system where someone could theoretically intercept the paperwork between the county clerk and the title office, swap in a forged version, and walk away with your house. DNSSEC is the cryptographic seal on the envelope. It was always available. Most people never used it. And until today, the title office wasn't even required to check for it. Mike Cardwell, the author of this post, set up DNSSEC 14 years ago. 14 years of running cryptographic DNS validation without incident. First on Bind 9, then Power DNS. The tools have been there. The standards have been there. What wasn't there was the mandate. This matters because DNS is the phone book of the internet, and phone books can be poisoned. Without DNSSEC, a sophisticated attacker can redirect your domain's DNS responses, trick a CA into issuing a fraudulent certificate, and stand up a convincing copy of your site with DNSSEC validation mandatory. That attack surface shrinks dramatically. The CA has to verify the cryptographic chain all the way back to the root zone. The real story isn't the technical change. It's that this took so long. DNSSEC has been deployable since the root zone was signed in 2010. 16 years to make validation mandatory at the CA level. 16 years where the lock existed, but nobody required you to use it. Cardwell's closing advice is worth repeating. If you own a domain, check whether your registrar supports DNSSEC. It might be a single click. That click means every certificate issued for your domain now has to pass cryptographic verification. One click, and the entire certificate issuance chain gets harder to subvert. We've been celebrating wins all episode. Pause time to talk about one that needs watching. Canada's Bill C-22. There's a term buried in Part 2 of this bill that most coverage hasn't caught yet. Electronic service provider. It's new. It didn't exist in Canadian telecommunications law before Bill C-22. And the definition is broad enough to cover virtually anyone who moves data across a network in Canada. That term matters because Part 2, the Supporting Authorized Access to Information Act, requires electronic service providers to build and maintain interception capabilities, then give law enforcement direct access to their networks to test those capabilities. Read that again. Direct access to test. Not respond to a warrant. Not produce records upon judicial order. The bill envisions law enforcement inside the network, verifying that the surveillance architecture works. Now, follow the logic all the way. If providers must build interception-capable infrastructure by law, and that infrastructure must be testable by government agencies, then every Canadian network becomes a surveillance-ready network by design. The capability doesn't activate only when a warrant arrives. It exists permanently. It's structural. The frustrating part is that Part 1 of the same bill actually represents real progress. The government genuinely learned from the Bill C-2 disaster. They scrapped the absurd warrantless demand power that would have covered doctors and lawyers, anyone providing a service in Canada, and replaced it with a narrow confirmation of service demand limited to telecom providers. Want to know if someone is a Bell customer? Law enforcement can ask. Want their subscriber data? Get a judge to sign off. That's a meaningful concession to the Supreme Court of Canada's privacy jurisprudence. Part 2 didn't get the same treatment. The data retention requirements are actually worse than Bill C-2. The secrecy provisions remain. The cross-border data sharing framework remains. And the oversight addition. Ministerial orders now require Intelligence Commissioner approval. Doesn't address the fundamental architectural problem. You don't need to worry about who approves the surveillance order when the surveillance infrastructure is already built into every network by statute. One commenter put it plainly. Democratic governments are converging on the CCP model. That's too blunt, but the architectural criticism holds. The question was never whether Canada's government intends mass surveillance. The question is whether mandating surveillance-ready infrastructure in every network is distinguishable from mass surveillance in practice. Follow the principle to its endpoint. If every provider must maintain interception capability, and that capability must be verified by direct government access, then the architecture is the policy. The warrant requirement in Part 1 becomes a formality layered on top of a system that was built from the ground up to watch. The tools to push back exist. Open Media and the Canadian Civil Liberties Association have killed surveillance bills before. They'll need to again. But this time, only half of one. We talked earlier about tools reshaping how we build pause. Now let's look at what happens when AI meets open source contribution at scale. I've mass reviewed pull requests where something felt off before I could articulate why. The code compiled, the test passed, but the abstractions were wrong. Layers that existed to satisfy a pattern rather than solve the problem. Turns out that feeling now has a name and a dataset behind it. Researchers at ArcScience studied cursor OA usage across open-source repositories and found exactly what experienced maintainers have been whispering about. Speed went up. Quality went down. PRs landed faster. But the code they carried was measurably worse. More duplication, shallower abstractions, the kind of technically correct but architecturally hollow contributions that create maintenance debt for years. This reminds me of something Fred Brooks wrote in 1986. No silver bullet. His argument wasn't that tools don't help. It was that the hard part of software is the conceptual structure, not the typing. The essential complexity lives in understanding what you're building and why. The accidental complexity. Syntax, boilerplate, the mechanical parts. That's what tools can eat. 40 years later, AI coding assistants are the most powerful accidental complexity eliminators we've ever built. And this study suggests that when you remove the friction of writing code, some developers skip the thinking that friction used to enforce. The craft of software has always been a dialogue between speed and understanding. When I pair program with AI tools, and I do constantly, the danger isn't that the AI writes bad code. It's that it writes plausible code so fast that I stop interrogating the design. The autocomplete becomes the architecture. What's genuinely exciting is that this research exists at all. Open source means open data. Someone could study this because the pull requests, the diffs, the review comments, all of it was visible. Try running this study against a proprietary code base at a closed shop. You can't. The openness that revealed the problem is the same openness that lets us fix it. The tools are extraordinary. The question is whether we use them as collaborators or crutches. And right now, the data says we're leaning. Remember that FFmpeg rabbit hole from earlier? Someone built exactly the kind of tool we love. LazyCut, a terminal video trimmer. In someone and Untitled, the typical video editing setup cost more than a house. An avid media composer ran about 80 grand, required proprietary hardware, and the software was locked to specific workstations. The democratization of video editing has been one of the great stories of personal computing. But there's a punchline nobody talks about. FFmpeg has been able to trim video with a single command for over 20 years. -SS for start time, -2 for end time, -C copy to skip re-encoding. 6 flags, done in milliseconds. The comedy here is that an entire industry of GUI trim tools exists because people don't know the command exists, or they know it exists, but they can't remember the flags, or they remember the flags, but they can't get the timestamps without scrubbing through a player first. LazyCut solves this in the most delightful way possible. It plays the video in your terminal. Actual video playback in a TUI, using Java for rendering frames as characters. You scrub to your cut points, mark them, and it hands the timestamps to FFmpeg. The whole thing is a Python script wrapping a tool that's been free and open for 2 decades. One commenter nails it. I don't find trimming videos with FFmpeg particularly difficult. And they're right. The underlying operation is trivial. What LazyCut actually solves is the workflow gap. Getting timestamps means opening a media player, scrubbing, writing down timecodes, switching to a terminal, typing the command. LazyCut collapses that into one interface. Another commenter built the same thing over Christmas using Claude Code in a couple of prompts, which is its own kind of wonderful. The tool to build the tool to use the tool is also free and fast. This is first principles engineering. What do you actually need? A way to see the video, a way to mark 2 points, a way to call FFmpeg. Everything else is overhead. This has been your daily tech feed for Hacker News for March 16, 2026. This podcast is entirely AI generated. Scripts by Claude Opus 4.6. Voiced by Quen 3 TTS. Not affiliated with Hacker News or Y Combinator. Now go tend something that matters to you. We'll see you back here tomorrow.